Today we're going to be solving Khan Academy problems which polynomials are in standard form. Now, when you're thinking about standard form, you're thinking about if they are in order. That's what I'm really doing. Standard form kind of just means, is it in the proper order? So proper order would be, let's say, for example, you have x squared plus x plus 1. This right here would be an example of standard form. Now, something that wouldn't be standard form would be a few examples such as b. So the reason that you know b is not in standard form is because you see that x squared is at the very end. Since negative 5x squared would have to be in the very beginning, you automatically know that it is not the correct answer. The next part is that we do acknowledge that a and c are in standard form. You're going to notice right here that it goes from 5 to 2. Does that mean that it is still in standard form? Yes. What about the negative 5 and the positive 2? Isn't this a smaller number than 2? Well, negative 5 is naturally going to be less than positive 2. That doesn't change the fact that when I'm trying to do my standard form, I'm thinking about it as where is the exponent at. So my exponent of 5 is correct, but the exponent of 2 is also correct because they're going in order from left to right. Just how we read in English, it's the exact same thing. You're going from left to right and making sure that it is in the proper order. As for b, once again, it had the exponent at the very end instead of going from the highest exponent all the way to the lowest exponent. Let's go ahead and try that out and give it a try. A and C. Correct? Awesome. Now, next question. A polynomial of the fifth degree with a leading coefficient of 7 and a constant term of 6. Okay? A polynomial of the fifth degree. When it's saying to the fifth degree, it is saying that, for example, if I had an x, it'd be x to the power of 5 with a leading coefficient of 7. When it is talking about my leading value, it means that the value that I have at the very front, let's say, for example, we have boxes, right? We have boxes. Now, here, all I'm saying is that the leading coefficient would be 7. The very front, the value at the very front should be a 7. That is what it means when it is saying the leading. Leading being leader, as an example. And a constant term of 6. So when we're thinking about constant terms, we're thinking about what is a value that does not have constants are those that do not have, oh, that looked horrible, do not have a variable beside them, right? So you can assume it as like a variable beside them and whatnot, but this is a general idea that I kind of tell people if they're struggling with the definition of constant. A constant is simply something that doesn't have a variable next to it. A constant here in our example are all of these. These are the 4 constants that we have in our problem. Now, we're looking for a constant that has a term of 6. So we automatically, by the way, just looking at the very last part, you already know that the answer is going to be D. Simply because all of them do not have a constant of 6. But naturally, we have to still test everything else. Is it to the 5th degree? Does the x have the power of 5? Yes, it does. Does the leading coefficient say 7? Yes, it does. Right? So I didn't even get to write my checklist yet, but knowing the 3 things that we're looking for, we can automatically already acknowledge that it is going to go ahead and be D as our answer. Now, let's go to the next question. 5z to the power of 3 minus 2z to the power of 4 minus 9z to the power of 2 plus z. What is the degree of the polynomial? So if we're doing the degree of the polynomial, this is a very simple problem, but because we've already done it actually. So to what degree? To what degree? So when you are being asked this, to what degree? I'm sorry if my handwriting is grotesque. To what degree? All I'm doing is when I'm looking at my exponents, when I write my x, what is the highest number that is written as my exponent? So that is all I'm looking for. Here, I have 5z to the power of 3 negative 2z to the power of 4, negative 9z to the power of 2. Z obviously would have a 1, but let's just kind of just ignore it because it has a smaller number. Now, I understand that 3 is the first exponent that you might see, and that is the one that you're going to assume. But this is not in standard form. Remember how we did earlier? In standard form, it would go from the highest exponent to the lowest. In this case, the highest exponent is 4. So to what degree? This is to the 4th degree. Let's go ahead and try that out. Put a 4, check it, perfect. Now, which polynomial are in standard form? Same thing that we did a moment ago. We're just going to go ahead and see which ones are in order. Remember that standard form has to be x to the power of 2, for example. And then, but as another example this time, let me say that it would be x to the power of 2 and 1. This would be standard form. Another example of standard form would be, say, x plus 1. These are both standard form. So don't get confused or tripped up with the idea of, oh, they have to be in order or they have to have every value in between them. Standard form does not require that. It just has to be in order in the exponent. So for example, I could say x to the power of 100 plus 1, and this is still in standard form. It doesn't matter if it's missing values or exponents in the middle. You're still looking and you're going to realize that it's still going to be the answer. So right here, 5, negative 2x. Now, don't forget that if you have an x independently, you are saying that it is going to be x to the power of 1. So here, the exponent is 1, and on the other hand, this one does not even have a variable, so we already know that this is not in standard form. X to the power of 4 minus 8x to the power of 2 minus 16. That is correct. So even though we're missing x to the power of 3, we know that this is in standard form because it's not missing anything else or they're not in the wrong order. 5x to the power of 3 plus 4x to the power of 4 plus 3x plus 1. Here, I almost made the mistake, right? But it's not in standard form because while negative 3 and a 1 are correct, the other two are in the wrong order. Here, you're going to notice that the exponent 3 happens before the 4, and that cannot be it. So this would be right, but this would be wrong, and that would mean that the whole part is wrong, or the whole problem is wrong. Now, we know that B is an answer, so we know that it is not going to be none of the above. The answer would then go ahead and simply be B. You can choose multiple, but perfect. Awesome. So if you're still having problems with these, I'm hoping to upload more of these. Go ahead and watch them. I think Khan Academy sometimes doesn't explain things the way it's asking them, but I love the questions. Honestly, you'll learn a lot if you're able to achieve and solve all of these problems. Good luck on your problems.